Good morning, students. Okay, today I will explaining the next topic, source transformations, the problems on source transformation. The last class explanation of source transformation, theoretical part. Now, today I will lecture source transformation problem. That's very simple problem. Okay, convert given current source 50 ampere invert internal resistance of 10 ohm is equivalent to voltage source. Here the parallel 15 amps to 10 ohm. This current source to voltage source. What is voltage? V into R. But here V into R as such. That is 50 into 10. That is 500 volts. RSC equal to RSC, 10 ohm in series. The equivalent voltage source. This is equivalent to voltage source. Voltage in series. Voltage is 500 volts. Just now calculated 500 because of 50 into 10 with the 10 ohm series resistance. Okay, the next problem. Find the voltage across capacitor 20 ohm reactance network shown in the figure, reducing the network to contain one source only by the source transformation technique. Here the given network. Just to converting 2 amps to 1 amps. This is current source equivalent to voltage source. What is voltage? Here impedance, that is I1 Z1. What is I1? 2 into 15. Here 2 into 15. That is J square 30. J square is minus, that is minus 30 volts. Here minus 30 means 30 at angle 180 degree with 15 J 15 ohm series. Why J 15? Because of this current source respect to the impedance value. That is J 50 series. Same thing you calculate V2, I2 into Z2. Just J1 minus J5. That is minus minus plus 5 at an angle 0. That is J square is minus 1. Here minus 2 minus plus 1. 5 volts, 5 at an angle 0 with minus j ohm in series. Okay, the next 15 ohm, 5 ohm, 30 to 180, 20 volts. Okay, minus j15, that is 5 at an angle. Just to calculate these two is now is calculate V1 and V2 using current source to voltage source. Next, combining inductive reactance and voltage source in the respective branches as shown in the figure, converting voltage source into the equivalent current source. Here voltage source to now in current source, that is 15 plus 5 20. Okay, next J5 as it is, here 20 and 5 15 20, here minus 20 minus 5 15 minus J20 as it is, 30 at angle 180 as it is. These two combining inductive reactance 15 plus 5 20. Here minus J5 as it is, 20 minus 5 15. Next here middle minus J20 as it is. Next 30 20 20 as it is, this J20 as it is. Next minus J20 minus J50, that is voltage to current source. Voltage to current source, that is V by R. V by R means 30 by 20, that is 1.5. 1.5. J20 as it is, series. Minus J20 as it is, minus J as it is. Next here 15 by 5, that is 3. 15 by 5. Here minus 2, numerator, denominator to numerator, that is minus plus 19. 15 by 5 is 3. Here these two are current source. Voltage source is converted to current source. Okay, next. Just now said no 1.5. How to get 1.5? 30 by 20. 90 with J20. 15 by 5, 3. Angle is minus 92 plus 90. That is minus J5 in parallel, J20 is parallel. Next, combining two current sources. That is 3 and 1.5. Why 1.5? Because of the minus J. That is 3 minus 1.5 with current source. The minus means that is reverse, downwards. Minus, sorry, plus J20 minus J5 is parallel reactance. That is 20 and 5 is a parallel. You get Z equivalent. Simplified network, that is V equivalent to I into Z. Finally, V equal to I into Z, I equivalent and Z equivalent. I equivalent is J1.5, Z equivalent is just now calculate minus J 6.6. We get V equivalent. Okay, next I equivalent, Z equivalent, VC with voltage source. This is the figure. I equivalent value 1.590, VC as it is, Z equivalent. Next VC as it is. Next these two V equivalent, that is 10 volts. Okay, then how to get 10 value? Minus J20 I J.66 plus 10 0, that is minus J minus 10, that is J26.6610, that is you calculate I value. Okay, 3.76. Next you calculate VC. How to get VC value? Calculate minus J20. Just to calculate current value and this value, current value and 0.376 0.375 into minus 90, we get 7.5. Okay, next problem. Calculate current through 2 ohm resistor in the network. Source transformation. These are the given network. This is also exam problem 2008 6 marks. Okay, converting 5 amps and 1 amps. Current source to voltage source. 5 amps and 1 amps. Here 5 into 3. Currents to voltage source. 5 into 3, 15. Here 9 into 1, 9 volts. 15, 7. 3 plus 4, 7. 7 ohm as it is. 3x, 17 as it is. 2 ohm as it is. 9 ohm as here. 9 volts. 15 volts and 9 volts. Okay, next you convert 15 volts to current source. How to convert 15 by 7? Why 15 by 7 means V by R. 7 ohm previous. 4 plus 3, 7. Okay, next 15 by 7. 7 ohm as it is, 7 ohm as it is. These two parallel. First 7 ohm, next 7 ohm. These two parallel. You calculate 3.5. 15 by 7. 17 and 3 Vx given in the problem. 2 ohm, 9 ohm. 9 volts. Here 7.5 volts. How to get 7.5 volts? It's very, very important. This is 15 by 7, 2.14. 7 and 7 parallel, 3.14. These two multiply. Okay, this is I into R. We get V. This is actually 7.449. You approximate 7.5. 17 ohm as it is. 3 Vx. 3 Vx into 17. That is 51. This is dependent sources with 17 15 Vx. 2 ohm, 9 ohm, 9 volts. 3.5 ohm. 3.9 is series. This value is series. Okay, next applying KVL entire circuit. Here 15 Vx minus to plus plus, plus to minus, minus 2i. Next minus 1.5. Next minus 29.5. How to get 29.5? Just previous 17 plus 3.5 plus 9.5. 17, 3. All resistance value combining. Okay, series because of 9. Total is 29.5 ohm. Just 15, 1. Vx is 2i. Why Vx is 2i? This, what is V? I into R. But here I is not given. I is find out. R is given. That is 2 into I. 2i as it is. 1.5 as it. 29.5 I 0. You get value 16 and I equal to 1.5. I equal to 1.5 by 69. You get 21.73. Okay, next problem. Using source transformation, power delivered 50 volts. Power delivered by 50 volts. Given network. This also exam problem 2014 5 marks. Just see the figure. Convert 10 volt source to current source. 10 volt source to current source. Where is 10 volt source? Here. This voltage source to current source. Very, very important. How to voltage source to current source? That is 10 by 3. Why 10 by 3? V by R. This 3 ohm. 10 by 3. 2 ohm as it is. 2 and 3 ohm is parallel. These two parallel because of 3 ohm. 10 by 3. This portion as it is. 50 volts, 5 ohm. 10 plus 10 by 3. Why 10 plus 10 by 3? These two current source are adding. Okay, same direction. These two current sources are adding 10 plus 10 by 3. That is 13.33. Remaining 2 and 3 is parallel. 1.2 parallel resistance. Okay, the converting current source to voltage source, we get circuit shown in the figure. This one. Okay, 5 ohm, 50 volt as it is, 1.2. Here 13.33 into 1.2. Why? Current source to voltage source. I into R. 16 volts. Just applying KVL entire circuit. 5 plus 2 minus 5, 5i plus 2 minus 1.2i. Next minus 16 plus 50, minus 2 plus 50. We get I equal to 34 by 6.2. We get 5.484 amps. It's current value. Power delivery 50 volts. 50 into I. Why 50 volt source? Just given in the data. Given in the problem. 50I. Just now we calculate current value. 50 into 5.484. You get 274.193. Stop the video. Okay, remaining next class. Next video. Thank you.